So greetings. I would like to welcome everybody to the 2014 Lawson Lecture. This is an annual lecture series put on by the Berkeley Seismolab to honor the contributions of Andrew Lawson, who made the infamous Lawson Report, which was a very good annal of the 1906 earthquake. And it's put on every year around April, the anniversary of the great 1906 San Francisco earthquake. To introduce our speaker this evening, we have the director of the Berkeley Seismolab, Dr. Richard Allen. So, welcome.
Thanks, Jen. Okay, so as Jen said, the idea of the Lawson Lecture is really to try and increase engagement between sort of academic community and the public in terms of seismic hazards and related hazards associated with earthquake. And as you may know, this year is actually the 50th anniversary of the Alaska earthquake, the Great Alaska Earthquake, a magnitude 9 earthquake. It was the largest earthquake in U.S. history. It's the second largest recorded earthquake that we have globally. About 120 people were killed in this earthquake, but only about 15 of them, if I recall correctly, were killed by the earthquake. More than 100 were killed by the tsunami, including about 13 here in California. So as soon as we started thinking about the tsunami, it was very obvious who we should invite to come and give our Lawson Lecture. Laurie Dengler is well known both for her studies of the tsunami processes, the science behind tsunamis, but also for her efforts to reduce the impact of tsunamis here in the US and, of course, around the world. So it's my pleasure to introduce Laurie Dengler. She's one of our own. She received her bachelor's and her PhD here from UC Berkeley in geophysics. She's currently a faculty member at Humboldt State University, which, in case you don't know, is located very close to Eureka, which is probably the most active earthquake region in California. This means that she probably feels earthquakes more frequently than we do, despite our proximity to the Hayward Fault. She was part of the steering committee for the U.S. National Tsunami Reduction Program and one of the authors on the first strategic implementation plan for that program. So in addition, she has been around the world, courtesy of earthquakes. She is an earthquake chaser. This is why I have my piece of paper. I'm going to tell you all the places where she has been part of the earthquake response team: Papua New Guinea, Peru, Indonesia, Samoa, Chile, Japan, and of course here in California. She's currently on the steering committee of the California Earthquake Country Alliance. She's a member of our very own California Integrated Seismic Network, CISN steering committee that the Berkeley Network is part of. And she's also the science advisor for the state tsunami program. She's received awards for this work over the years, of course. The NOAA 2001 Richard Hagemeyer Tsunami Mitigation Award, the Humboldt State University's Scholar of the Year in 2008, and the Alquist Medal for promoting earthquake safety in the state of California in 2009. So, without further ado, let's welcome Laurie.
All right, let's see. Can you hear me all right? Yes. Oh, good. I get to run around. That's good. Thank you so much for inviting me back. I actually gave a talk just about a year ago in the Earth Science Building. I don't remember its new name. It's always be the Earth Science Building to me, where I spent much of my youth that went on until I probably spent more time there than most people because I figured I could grow a much larger network of colleagues if it took me 10 or 12 years to finish my degree as opposed to the normal 5. Many of you I've worked with over the years. It's really a pleasure to have you come today. So I'm going to be talking primarily about tsunamis. And I want to convince you there actually is a link to Lawson because there is a tsunami in the Lawson Report. There was a tsunami produced by the 1906 earthquake. Geist and Zoback wrote a paper about it in 1999, attributed it to a step over, something that is of concern in the San Francisco Bay Area because there are a number of strike-slip faults that step over. And when strike, slip, faults step over, they cause the ground to either drop down or bulge up, and that can produce a tsunami if that happens to be underwater. I did spend a number of years in the mid-2000s studying the tsunami hazard of the San Francisco Bay, and one of the things we looked at very closely were these stepovers. And if anyone wants to ask me about that, you can do so afterwards, or please email me. This is the last mention I'm going to make of Lawson. A little bit of Tsunami Basics. I know it's a mixed audience here. Some of you probably know more about tsunamis than I do. But in case there are a few of you here that it's relatively new, I want to make sure we're all kind of talking about the same thing. So I think it's unfortunate that we call tsunamis waves, because we're all very familiar with waves that hit the coast. They curl, they come in every 7 to 14 seconds typically. Every now and then it can be as long as 20, 22 seconds. We know what a wave looks like. Well, a tsunami doesn't look anything like the waves that we're familiar with. Extremely long period, so that when they come in at the coast, they're basically coming in straight. They're coming in faster, they have a lot larger volume of water, and they may continue to come in for 15, 20 minutes. They may then be very still, like a lake, and then they may go out for another 15 minutes. Or maybe it's only 5 minutes, or maybe it's closer to an hour. Tsunamis are tricky, and that's one of the things that makes them so difficult to prepare for. The other thing that happens with tsunamis, this is Eric Geist's animation of a single surge interacting with the Northern California coast. So this is north in this direction. Here is Cape Mendocino over here, and I live right there. And you can see how this single surge continues to create oscillations, partly because of the shape of bays and also because of the shape of the shelf. This was actually recognized in a great study shortly after the 1964 tsunami. It's not just the North Coast that has this characteristic of really long oscillations. Basically, every part of the California coast, you see the energy gets trapped on the shelf and it continues to rattle along, in some cases for days. The 2011 tsunami, we could see it on the Crescent City gauge for almost a week, just under 7 days. Similar thing happens in the Santa Barbara Channel. In the 2011 tsunami, the largest amplitude signal in Santa Barbara actually occurred more than a day after the first signal. And that's because we still had these oscillations in the channel when the reflection bouncing off of South America came back and interfered with it. So we're talking about a phenomenon that lasts a long time. When we talk about tsunami height, I get really frustrated when somebody says, well, how high is it going to be? As if there's some nice single value, some elevation. It's just going to be 35 feet everywhere. It's complicated. You tend to have higher values in some places than others. This illustrates some of our terminology. Water height at any particular place. I'm going to be showing you values from the Crescent City tide gauge. That's going to be a tsunami height, not at the maximum extent of inundation. That's what we call run-up. So if you happen to see a tsunami catalog, you'll see it divided into run-up heights, which are not necessarily the highest elevation, because sometimes it may sloosh down here and the elevation may be low. If this were flat, it would eventually stop, run out of energy, and that run-up height might not be a really large value. One of the best places to visualize run-up height, a photo that Jose Barrero took in Indonesia, Sumatra, and you see this stripping of all the vegetation, which is a great visual way. You usually don't see it nearly that clearly. Most people, when we talk about tsunamis, think about water height. It turns out water height is not usually what does the damage. What does the damage is high velocity water, especially if there happens to be a lot of debris in it. So this is the 2011 tsunami in Crescent City, and all of the damage was done by fast-moving water, especially with debris in it. The water never got above the normal high tide mark. I'll actually be showing you a merogram in a bit. So the fact that the water was moving really, really fast. So it's not just how high the water is, it's how fast it's moving. We talk a lot about travel time, especially when we're dealing with tsunamis that are far away from us, because you want to figure out when you need to get people out of harm's way. So here's a simple travel time map, different from a seismologist's travel time map. And it turns out that estimating this arrival of the first part of a tsunami is one of the easier things to do in the tsunami world, because it's really only a function of how deep the water is. So relatively easy to calculate. And so each one of these bands is an hour, and this is one of many variations on the 1964 travel time across the Pacific. And you can see that the area that we're interested in is 4.5 to 5 hours away from the source. All right, with all that, I am going to show Nathan Becker's animation using the rift model of the propagation from 1964. And this is speeded up, obviously not in real time, or we would be here for many hours. And you can see on the top elapsed time after the earthquake, and here we can see the universal time. So you can see this energy travels forth. It's not one wave, it's many oscillations. Here you can actually see that reflection coming back off of South America. And I'm sure that Santa Barbara probably had some trapped energy in 1964 from that reflection. This shows the computed peak amplitudes. Tsunamis are directional. They always exhibit directionality. I used to call it directivity until one of my seismologist friends says, you got to remember your seismology. Directivity means something in seismology. So we call it directionality. The maximum energy is perpendicular to the fault, but it's not uniform because it's a function of a whole number of things. The slip on the fault and the seafloor bathymetry, which tends to guide the energy in certain ways. And you can see our nice little fickle finger of fate pointing right at northernmost California. Now, it's kind of an interesting feature of the Pacific bathymetry that no matter where a tsunami comes from, it gets amplified at Crescent City. But that's a subject of another talk. A lot of my talk is going to be history. I'm really interested in history. We're talking about an event that occurred 50 years ago. And in order to get a sense of where we are today, what's different, what's similar, it's really useful to go back and look at exactly what happened in 1964. And I've used strictly Pacific Standard Time, March 27th and 28th, 1964, we were still on standard time. So just so that we're using the same units of time, the earthquake occurred at 7:36 p.m. Pacific time. Good Friday. had you been in this building at the time, which did not have the Richard Hagemeyer letters on it, it was just called the Honolulu Observatory at this time, a place where Mike Blackford here has spent many long productive hours. And thanks to Mike and also Barry Hirschhorn at PTWC, they managed to find the original log for me on what happened in 1964. And I think the seismologists in the room will find this kind of interesting because we've become so accustomed to getting locations out literally in minutes at most. So the first alarm is 8 minutes after the earthquake. By then, if you guys haven't got a location and magnitude out, you know, that's a big black mark, right? Well, the alarm first sounds 8 minutes after the earthquake. And then it takes a little while for people to actually get to the office. This is Good Friday. I'm assuming it was probably a holiday. Certainly, people were probably not in the office at the time that the event occurred, so they had to get on their bicycles and go in. And about 15 minutes later, they actually request information from other observatories. Because at that time, they're not getting telemetered data from all of the important seismic stations in the world. They actually have to request, hey, you know, we'd really like to know your P time. And Manila seems to be the folks that responded first. I thought that was interesting. It's probably the U.S. military at that time in the Philippines. So it takes about 6 minutes for the information to come in from the Philippines. And Hong Kong, Guam, Japan. Berkeley is a little slow. I don't know why. And then we have Tucson. And finally, about an hour and 15 minutes after the earthquake, we get a location. That seems like forever, especially as that tsunami. Imagine that tsunami is propagating. We don't even have a location. And notice there's no mention of magnitude at this point. The first bulletin comes out at 9:02 p.m. And it's also interesting to notice that the word tsunami is not used. Be interesting to sort of pore through the logs and see when tsunami. Mike, do you know when they first started using tsunami at PTWC? At this point, it's strictly either called tidal wave or a seismic sea wave. Seismic sea wave was kind of the preferred terminology used at that time. And a location is given, not known if a tsunami's actually been generated. And there's one time estimate, which is if there was a tsunami, this is when it's going to arrive in Hawaii. Note, there is no mention of magnitude. We actually, before Peggy and I were looking through the catalogs to sort of see what those magnitudes were at the time, it actually took them more than a decade to get what we now consider the correct magnitude because moment magnitude did not exist at this time. So the magnitude estimates ranged between about 8.4 and about 8 and 3/4, I think was the way it was listed in one of the catalogs. So, but those magnitudes are not part of these messages. At 9:30, a second bulletin was issued. At this point, they had estimated the arrival time of the first surge in a number of locations. And buried in here is Crescent City at midnight. Now, at that time, this information went to the California Disaster Office. And for reasons I don't quite know, it took them nearly 2 hours to actually get a bulletin out to law enforcement agencies in the state. The bulletin first arrives in at the Del Norte County Sheriff's Office at 11:08 in the evening. Now, to kind of give you a sense of what that means, this is an animation that was done by the Japanese after this event, freezing the event at about 3 hours after the earthquake. So, first of all, there's a little bit of vertical exaggeration. The actual amplitude of this tsunami in deep water would have been maybe that high. When you see, and which we can now see on these deep ocean instruments, the DART buoy system, when you see a tsunami that is approaching a meter on a deep water instrument, it makes you really nervous. And that's what we saw on March 11th, 2011. It was like, wow, this is that big in deep water. This is a scary tsunami. So, obviously, the height here is really exaggerated. But it certainly illustrates how you see much higher amplitude near the coast. And it also illustrates the wavelength between successive peaks and troughs. So we're talking about hundreds of miles between hundreds of kilometers between successive peaks and troughs. All right, Crescent City is located right here. This is where the tsunami is when they get their first official notification. And when you're an emergency manager, that might make you a little nervous. Obviously, they didn't have this picture. I'll try to give you a sense of what it was like had you been in Crescent City. This is the actual merogram. I'll show you where that was located in a later slide, in the Crescent City Harbor. And here we have the height of the water in meters. 0 is what we call mean lower low water. It's the average of all the low tides throughout a year, and that's our reference level in the U.S. And you can see that the water level is rising, and this is the point right here when that first bulletin arrived. And it nearly coincides with a pretty good high tide. In other words, little over 8-foot tide, around 11:30 in the evening. So that first bulletin comes in. They're actually not quite sure what to deal with it. And it takes another 20 minutes before they get a second bulletin, where the sheriff's deputies actually start knocking door to door. They're knocking door to door as the first surge arrives. In fact, most of them don't even leave the area that gets inundated from the first. So a couple of things about this. Those of you who think tsunamis are always preceded by a drawdown, you're wrong. There are just as many tsunamis that come as a positive wave as opposed to a negative one. Often people tend to see a negative wave. Often it's easier to observe, but this was definitely observed. So here is the signal on the tide gauge, and it's pretty significant. We're talking about and these are total water heights. In other words, the tsunami riding on top of the tide. We don't call them tidal waves, but tides are really important because they certainly give them a boost. So we're talking about something, our normal high tide is about here. And to give you a feel for what happened, I had an undergraduate student who did a great GIS project this year trying to reconstruct what happened in the '64 event. And based on eyewitness accounts and on the water height on the merogram, we think this is roughly the area that was probably flooded by the first surge. Now, I actually have a real photo of inundation that was very similar. Not from '64. This is 1960, the tsunami that came from Chile, that actually caused damage. it caused flooding. And it caused flooding that was almost, basically the same as what we saw from the first surge in '64. So that's important to have in your mind, that 4 years earlier, they had experienced something that was virtually identical to what the first surge does in 1964. So then we get the drawdown, and people say, yeah, the water went way out in the harbor. And then we get a second surge that comes in about a half an hour later. And it's smaller. Then we have a long period, 40 minutes, where nothing is happening. Well, we always tend to use our own past experience to project what's going to happen in the future. So here we've just experienced the identical flooding that occurred 4 years before. We have a smaller surge, and nothing seems to be going on. So what is the logical assumption? It's over. We've had our tsunami. It's over, so what are we going to do? Now, we know that many people did evacuate out of the area, just based on a lot of eyewitness accounts. After the first two surges, many of those people went back. They went back for a variety of reasons. Some people had businesses in the area. They wanted to start cleaning up. Some people wanted to party. There was a group of 7 people that were celebrating someone's birthday. They went to they owned a bar on Citizens Dock. They opened up the bar. They had a party. Unfortunately, all but 2 of them died. So we don't know for sure what happens next because the tide gauge gets knocked over. We know that a third surge comes in and it's clearly larger than the first one. Based on eyewitness accounts, it came in on the order of an hour after the second one. And here is the tide gauge. This is the end of the lumber dock, and the tide gauge housing actually stayed standing, but the flooding was sufficient to knock over the instrument. The amazing thing is they were able to recover the paper record. And then all of the eyewitness accounts talk about 4 surges. And they talk about the 4th being the largest. And we have a pretty good idea of how high it was because it managed to leave just over top this main breakwater. Now, one of the interesting things about this tsunami, it came from Alaska. So it came from this direction. Yet it didn't wash over this way. It actually swept around and came in this way. And that has to do with the offshore bathymetry. And what tends to happen in these crescent-shaped bays is that the tsunami goes faster in deeper water, and if you have bathymetry that is curved, it literally swings the tsunami around and brings it in from the south. Half Moon Bay does exactly the same thing. And we tend to get amplification there as well. And you can see how the debris is all up against this side. There's almost no debris on this side. So based on the fact that there's a little bit of debris that suggests it just got over this breakwater, the elevation of that breakwater is what we use to estimate the maximum water height. Now, at this point, the tide would have probably been about down to here if it had just been a normal tide. So we have about a 15-foot tsunami riding on top of what is already about a 4 or 5 foot tide. So tide becomes really important. And I'll show you a slide in a moment of what happened in 2011. Mother Nature was not kind in 1964. Large amplitude signals coming in on top of already a pretty high tide. This is the surge that seems to have done most of the damage. Now, this is worth the price of admission alone.
This is where it all began.
This is the actual CBS coverage
what was once a breakwater, smashing it to bits and invading this quiet
taken
town.
right after
And
the
it's here
tsunami
that
in Crescent City.
Will begin first with another breakwater to stop the eroding seashore, and as the people in Crescent City pray this Easter to protect the town from another disaster. The rebuilding is a staggering job. 60 square blocks were hit, 14 of them all but stripped of their buildings. This Sunday, there is no Easter parade down Front Street, but at least the street itself will be ready for traffic again soon. You were seriously injured here in Crescent City, and a score will bear the scars of this disaster for life.
It just kept a-jerking and pulling and shaking, and then all of a sudden, I don't know how long it took, but all of a sudden everything was calmed down and the house stayed still. And I thought I was in the same place where my house was. But instead of that, I was way over back of the Crescent Lumber Company.
Now, Mrs. Bartlett, you were in bed when this happened.
I was in bed when it happened, and I couldn't get up because the roof was on me.
For how long was the roof on you?
From the time that it started until they found me at 10 o'clock.
Anyone recognize who that is?
I never want to go through again, and I hope I never live to see anybody else go through it. Oh, it was terrible.
Are you going to go back and rebuild your home?
I haven't got no money to rebuild nothing.
All told, the damage estimate stands at $40 million. But reconstruction of buildings usually takes far less time than the healing of human wounds. This is Terry Drinkwater reporting from Crescent City, California.
He was 28 when that was. Some of you may remember Terry Drinkwater. He was a wonderful CBS reporter that unfortunately died of cancer in his 50s. We managed to find this tape when our local CBS affiliate switched to being NBC about 15 years ago, and they dumped all their CBS tapes in a dumpster and said, if you want to poke through it, fine. And we found this. We learned a lot. There were a lot of studies done after 1964, not just in Crescent City, but many studies in Alaska. Because, as Richard mentioned, the overwhelming majority of the lives lost were due to the tsunami. There are actually 14 deaths attributed to the tsunami in California, 10 in Crescent City, 1 at Klamath, 1 in Bodega Bay, and 1 longshoreman at the Long Beach Harbor who was hit by a chain that snapped when a large ship suddenly jerked right about the time when one of the surges should have been coming in. So not absolutely 100% sure that was due to the tsunami, but it was a very unusual event, and the timing was such that it matched. About 15 years ago, I had the pleasure to meet Orville Magoon, a fascinating man who experienced the 1946 tsunami up in a tree when he was 18 in Hawaii, who became one of the world's foremost experts in jetty construction, working for the Army Corps of Engineers, but always had a fascination with tsunamis. And after both the 1960 tsunami and the 1964 tsunami, managed to convince the Army Corps to let him come up to Crescent City. He actually mapped in other places of California as well. And they gave him 2 days to do a detailed mapping of the impacts. To this day, I think it is one of the best studies of the interaction of structures with fluids that I've ever seen in a post-tsunami survey event. In fact, I wish future post-tsunami surveys would really look at the detail that he did. So this shows his mapping of the maximum inundation But in addition to that, he also noted the character of the damage. These are two air photos collages he put together. Here's 1962. Here you can see Elk Creek. Here you can see on April 1st, just a couple of days afterwards, you can see the amount of erosion. You can see how the creek has just been reamed. And the group that had been partying at a bar over here, for reasons I still don't understand, they could have very easily gotten out of the flooding area this way. But one of the young men in the group saw a boat in the harbor right here, got the boat, got everybody into the boat, sort of at the time of the maximum inundation of the fourth surge. They managed to get all the way here, all the way up here, get under the bridge, under Highway 101, and then they were almost ready to get out. They got caught in the outflow with all the debris and basically got caught in a log jam. 2 of the 7 survived. The other 5 did not. So here's just an illustration of the area using Orville's map. And this year I had a senior thesis student who has GIS skills. She took Orville's data, and she actually made a whole number of really interesting maps from it that illustrates the kind of damage. These contours are in feet, and these are feet above the land surface. So they're not relative to mean lower low water. So 8 feet, 6 feet, 4 feet, 2 feet, and then here's the end of the inundation. And a couple of interesting things. You can see how the tsunami actually was guided by streets. We see that often. You can see the low area. It penetrated further. And all of these black buildings are buildings for which we know exactly the kind of damage that occurred in them. And one of the types of damage was what you heard the woman in the hospital talking about. Literally, the house was floated and came down in a different position. So this is Kreider's house right here. You can see the foundation. It was located right there. It floated in that direction. At this time in Crescent City, very few houses were secured to foundations. And it turns out it only takes about 1.5 feet of water to float a wooden structure. It's interesting when you actually look at how things have been displaced. The majority of things have been displaced in the outflow direction. And it matches eyewitness accounts that the water actually came in relatively slowly, on the order of 1 foot a minute. Much stronger currents in this particular case in the outflow, when water tend to be channelized and moving faster in certain directions. Another cause of damage, again, Orville Magoon did this in 2 days, were a lot of structures that literally burst at the seams. So you can imagine that the water comes in, it floods the building, the water goes out, the water inside the building continues, it doesn't drain as quickly, and the differential stress pops out the side. So lots of structures exhibited that bursting, buckling of walls due to the pressure differential. Debris was a huge part of the story. It's kind of interesting. One of a classic paper that was published in the early 70s showed the famous tetrapod that had been knocked off of its base and displaced, about 1 meter. And they calculated how fast the water had to be moving, which was outrageously fast. And neglected to take into account that actually a redwood log had hit it. So when you have large woody debris or other debris entrained in the flow, a lot more damage happens. Now, 1964 was an exciting year in California. There were actually 2 major water events. We're about to recognize the 50th anniversary of the great floods of 1964, the Christmas floods. And those floods, which actually killed more people in California than the tsunami did, deposited a phenomenal amount of debris on California beaches because it was the heyday of the logging world. Had the flood occurred before the tsunami, we probably would have had even more damage because there would have been a larger source of woody debris for the tsunami to pick up. Fires were an issue. Now, there was lots of focus on what happened in 1964. And I've showed just a couple of illustrations from the Garcia and Houston probabilistic assessment of tsunami heights along the entire west coast of the U.S. This is actually just San Francisco Bay and Puget Sound, but they actually did a probabilistic study of the entire west coast of the U.S. They came up with 100 and 500-year tsunami height estimates. They only assumed Aleutian sources, so we wouldn't recognize that as being terribly useful today. But for the time, it was pretty advanced. This was in Wilson and Torum's report, looking at the really long duration and the characteristic of tsunami signals at Crescent City. And they recognized this sort of interesting shape of the continental shelf where you basically, in this sort of bowl-shaped topography from Crescent City down to Patrick's Point here, and they did an analysis that showed the characteristic periods of oscillation that we see in Crescent City tend to match that kind of a pattern. Another interesting legacy of the 1964 tsunami was Reconstruction. Reconstruction and recovery, to me, is the area of emergency planning and response that we're the weakest at. And we're not the only ones. Most countries, Japan is having a really hard time with post-tsunami reconstruction. What do you do to facilitate recovery, to get on with a new, vibrant economy? Now, this is a map that shows the Army Corps of Engineers reconstruction zone. The Army Corps of Engineers came into the area, they drew this line on the map, and they said, if you own a building in this, you either have to bring it up to present code with no help whatsoever, or you can sell it to us at market value and we'll destroy it. So what do you think most people did? Almost every structure in that zone, even if it had not been damaged, ended up being bulldozed. This shows this is 2nd Street, right there, looking to the east, right after the tsunami. This is the main downtown drag. These are shops, cafes. This was downtown Crescent City. And old-timers remember it as a dynamic, busy place. This is what it looked like in 1984. The reconstruction destroyed all the existing buildings. They actually removed 3 blocks of 2nd Street, and they put this very funny walkway. It was called Tsunami Landing. And the only thing it was of value is it had a high water mark on it. Whenever I took people on tours there, I would take photographs of them in front of the high water mark. But there was no space for stores. This was an absolute ghost town. This finally got removed about 1.5 years ago because it was rotting. It's still a ghost town. The reconstruction planning basically destroyed the soul of this town. It got most of the people living in the area out of the area, which reduces vulnerability. With the exception of this building right here, the 4-story Surf Hotel, which stayed empty for many years and now is a senior citizens home. It's the only population that is not capable of walking out of the tsunami zone if we happen to have a major local earthquake. So lots of lessons here. clearly how buildings respond to tsunamis, how communities respond to recovery. If you ask a lot of the old-timers and say, what did the most damage in the tsunami? And they'll say, the Army Corps of Engineers. No plan was in place, so it was very easy for the Army Corps of Engineers to come in. Lots of publications, much gray literature reports, and almost all of that kind of went onto back shelves, into musty corners, during what I call the tsunami quiet years. This is a graph I put together a couple of years ago, looking at tsunami bulletins in Northern California if we had today's protocol. Obviously, there was no tsunami warning center at all prior to 1949. That's when the Pacific Tsunami Warning Center is first established. But based on where these earthquakes are located, we can use present-day protocol to see that we would actually have had a fair number of bulletins. The red are tsunami warnings. There's one event in 1980 that would have gotten a tsunami warning on our coast. It was a 7.2, right offshore of Trinidad. My first earthquake on the north coast, I'd been there less than a year. It caused our antique clock to smash off into little bits because it was just sitting on top of a bookcase. And it was not a far-field event. In fact, many of these red lines are not far-field. So you can kind of remove that and see that we really didn't have very much happening as far as big far-field tsunamis. And what happened in those quiet years is we did get another tsunami warning center in Alaska. There were certainly some events. Mike Blackford remembers some of those times. Things did happen. But it was a time when the discipline of being a tsunami scientist, well, we could have fit you all in this room, probably in the center section. Would you agree with me, Mike? Maybe even in the first 7 rows. It was a very small field. In the 90s, a lot of things start happening. We have a resurgence in tsunami interest. Part of it comes from the technological side. The tsunami modelers are finally developing models that seem to have some credibility. We have the 1992 Cape Mendocino earthquake, which I also felt really strongly, which produced a local tsunami. Small, but it certainly engendered a lot more interest in the Cascadia subduction zone. 1992, Nicaragua, we have a tsunami earthquake, an earthquake that's not all that big, but produces a really big tsunami. It is the first international post-tsunami survey team study that didn't quite do as much as what Orville did all by himself back in Crescent City in '64, but it establishes the protocol for doing these post-tsunami field surveys. We have a big tsunami in Okshiri. 1994, we have a Kuril Islands event where a warning went sour, which means a warning was issued. There were unnecessary evacuations that required a rethinking of the tsunami system. And then in 1998, we have what is probably a landslide-produced tsunami by only a magnitude 7.1 earthquake, or 7.0. So really a lot of interest in tsunamis. But the education and what we learned from '64 didn't really carry over. And I'll just give you a couple of examples here. 2006. This was an 8.3 earthquake in the Kuril Islands north of Japan that was assessed by the tsunami warning centers to really not pose a hazard of flooding on land. So the warning was canceled, and 6 hours after the bulletins were canceled, we had $28 million worth of damage in Crescent City. Definitely rose a few eyebrows. Not only that, we have the harbor master and assistant actually walking on the docks as the strongest surges are coming in completely unaware that a tsunami consists of more than one surge. So all of the things that, we had certainly been aware of for many years clearly had not gotten down to the users. We were very fortunate that they managed to get off the dock before it was pulled away. All of the damage due to strong surges. 2011, we actually did fairly well as far as evacuation. We were incredibly lucky in that the largest surge arrived right at low tide. If we had put it on top of the high tide 18 hours later, we actually would have had flooding similar to what happened in the first surge in 1964. But we realized we did have one death. There are only 2 deaths outside of Japan from this tsunami. One was in Indonesia that was kind of a freak accident. The other was at the mouth of the Klamath. Not at this location, but for the same reason that all of these people were crowded on the beach to watch the tsunamis come in. 3 young men at the mouth of the Klamath got swept away by the surge that came up the Klamath, similar to what we see on the Mad River there. 2 of them managed to get out. One's body was found 3 weeks later, 380 miles to the north. So let's talk about what 64, if a repeat of 64 were to happen right now. I had to stop that as fast as I could. And I already stopped it. That's 20 minutes. We would have had our first bulletins being issued 2 to 4 minutes after the event. I can't stop the animation that quickly because of our current capacity for events like this. And it doesn't even matter if Palmer is completely offline, we hope, that we should be able to get that information out for this sort of event in about 4 minutes. Preliminary location, preliminary magnitude, and that magnitude is going to be too low. I can guarantee it. Because it's still really hard in 4 minutes. It's impossible right now in 4 minutes to really estimate the full magnitude of the event because the event's still rupturing. We don't know the full extent. But in 4 minutes, we should be able to identify whether we're getting close to 8 or a little over 8. And so that's a heads up right away coming from Alaska that we could be dealing with something big. Okay. By probably less than an hour after the event, it has, I'd say more like a half an hour, it's passed over some of these deep ocean instruments. And so we've got the first forecasts using real data from the tsunami, estimating the likely water heights along the entire west coast of North America. I mean, we've got information in Alaska too, but it's too late for Alaska because the first surges are coming in Alaska in tens of minutes. Now, as the tsunami continues to propagate, it actually passes over more of these deep ocean instruments. One is able to refine. And at present, well, in the 2011 event, the forecast for Crescent City was 2.5 meter maximum amplitude tsunami. It came in as 2.47. Now, I think they were lucky to be that close, but it illustrates how much more information that we basically have now when these events occur. So we've revamped the communication system. We test the communication system. At least in northernmost California, we actually use the real live codes. We've had 6 tests using the real live codes. We've had evacuation drills. Maybe we'll do okay, or we'll do better with the next far field event. So here's a location of some of our starring earthquakes that have posed a tsunami hazard to the west coast, well, certainly California. And they come from a variety of places. The good thing about all of these stars is they are at least 4.5 hours away. I'm a little nervous about Alaska because, you know, it's really nice to have 13 hours. 9 hours is pretty good. 4.5 hours is going to be a little bit tight in terms of really trying to move in a full-scale evacuation drill. But I think we've gotten much better. The problem, the challenge, is that 64 was probably not our worst-case event. Here shows some of the damage in Crescent City. Here's a core taken just near there. At the very top of the core, you can see a nice little sand layer that was deposited by the 64 tsunami. Another little sand layer that was deposited by the 1960 tsunami. And down at the bottom, something a whole lot bigger, which may be a megastorm. We can't rule that out. But it comes in as being about the right time for the last major tsunami generated by our own big earthquake system. And we don't only have geologic evidence, we actually have eyewitness accounts. This is Surker, who is a Yurok Indian, who was one of Albert Kroeber's informants. Kroeber was still lecturing in my day at Berkeley. I never took his class, but everybody said he was really terrific. And Surker told a number of stories, and at least 3 of them talk about tsunami events. So this is the present-day mouth of Redwood Creek, where the Redwood National Park Information Center is. One of my colleagues, Deborah Carver, spent a lot of time correlating native stories with actual physical evidence. So the E's are all earthquake stories, the red E's. The brownish ones are physical evidence, in this case liquefaction. The blue T's are tsunami stories. The pale T's are paleo-tsunami deposits. So certainly seems to match up. We also have a lot of other evidence, including the written stories from Japan. If you take Surker's story in particular, this is the present-day mouth of Redwood Creek. That's Redwood National Park Information Center. That's probably what we're looking at in terms of inundation. Last 2 slides. The near-source tsunami is much more of a challenge, especially in the southern part of Cascadia. It is not a technological problem because technology won't help you when the first surges arrive in 10 minutes. And I don't care how many water sensors you have right next to the coast. We're talking about an earthquake that produces at least 1.5 minutes of strong ground shaking. We're talking about communication networks completely disrupted. We cannot rely on technology to get information to the people who are experiencing this earthquake. In Japan, there were many tragedies, but one marvelous success story in Unosamai near the city of Kamaishi, a school where the students drilled and drilled and drilled, and here shows them actually evacuating as the tsunami is attacking. Not a single child, elementary or junior high school child, died in that particular tsunami. Trying to get across the message that a near-source event is different than a far-field one. One of the things we worry about is that drilling and drilling for the far-field event actually locks the wrong thing in people's minds, that they're going to expect to hear a siren. They're going to expect to hear some kind of official announcement, where in fact what they're actually going to feel is 1.5 minutes of ground shaking, or maybe 2 minutes, or maybe 2.5 minutes. So this is what we have to keep drilling and drilling and drilling, is they have to figure out how to do all these things without any assistance, without any guidance. And so we've learned from 1964, we've relearned from 1964, but our biggest challenge is making sure that everybody understands that when the ground shakes, you got to protect yourself. If you're in a tsunami zone, you need to get out of it. The shaking is your warning, and you need to stay away. In 2004, 39 Americans died in the Indian Ocean tsunami. They died in Thailand. They died in Sri Lanka. One of them was a neighbor of mine. None of them lived in those areas, but they visited. Everybody here visits the coast. There is a potential for a significant tsunami along every coast if you give a long enough time. And so it's really important to understand. It's great the advances we've made with the far field event. It's essential to maintain the tsunami warning system. It's essential to keep remembering the lessons from '64, but we don't want to forget Mother Nature's warning. Thank you very much. And I suspect that there's time for questions if anyone wants to ask me a question.
And I can pass the microphone to anybody who wants to ask.
And Orville Magoon is here, right there. Orville, please, everybody give Orville. You don't need to stand up. Give Orville. Anybody doing post-tsunami field surveys, he is the master. And that wasn't even his main job. His main job was designing what is probably the most resilient jetty in the world. It happens to be in Humboldt Bay. So, thank you, Orville.
Fantastic lecture, Laurie. Very impressed.
Well, I stole information from a lot of people. That's what I'm good at doing, is, yes?
So Laurie, at the beginning you insisted on how long it took for the Alaska warning, but you mentioned that there was about a few minutes or maybe 10 minutes for an alarm to sound. So in Hawaii?
Correct.
So how did they get that? Somebody called up?
Mike, can you describe how the alarm system worked at Hawaii? That there was basically a trigger on...
Of course, I wasn't there. I was here in '64, but...
Mike actually ran the Pacific Tsunami Warning Center for a number of years, so...
Yeah. Well, basically, I believe in '64, the center probably had something like the worldwide standard seismic instruments, such as some press Ewings and some short period instruments. And knowing the protocol at that time, they were probably waiting to measure the largest amplitude Rayleigh waves. And of course, they were probably off scale. So
they would come. It would take a while for them.
Exactly. That's probably the
The 8 minutes. You think the 8 minutes?
They probably
or?
started with something like basically a MB, and they probably calculated an MB. I'm sure that was in the procedures at that time, but of course that was, what can you say about that at that time? So they really probably didn't really have a good handle on the magnitude, as Laura.
No,
Laura
I mean,
said earlier.
throughout the entire log, magnitude is never mentioned.
Yeah.
It's just, it was clear from the event, and Peggy and I and Mike were looking at some of the actual seismograms today in the Berkeley archives. You knew it was a really big earthquake. You didn't really need to know what the magnitude was to realize it was a really significant event. And clearly that's what they were responding to.
They would have located it somehow.
Well, they located it. It looked like they needed to have, at least in the log, they don't talk about locating it until they had about 7 or 8 stations.
I guess the question is, why would they know that this would be a tsunami if they didn't know where it came from, more or less?
Well, I know at the time, because the globe was still there, they actually, I mean, the globe that was there when I was there in the 90s
Drawing circles.
actually
Drawing
had holes
circles.
in it. I mean, the various places were like Berkeley and Hong Kong Observatory and what have you, and they used a tape on the globes in order to triangulate the location.
Right, so but that comes later, right? With one station in Hawaii and everything saturated.
Well, they didn't. They did not do it just on the Hawaii station. They clearly waited till they had all of these stations before they have their first epicenter estimate. The alarm is large earthquake.
Yeah, the alarm would have been
Right.
On one of the instruments
Right.
there of some sort.
And actually, that's the way the system still works. The first bulletins are based entirely on seismic information. And we work that way today. And it will say that, there's been no confirmation that a tsunami has been generated. But based on the location and size, it's possible.
We could probably do one more.
So you pointed to some of the problems with the response after the tsunami in terms of what the Army Corps of Engineers did in Crescent City, and they kind of basically destroyed these various blocks. So with the benefit of hindsight, what's the right answer? What should be done in Crescent City?
Boy, you have put your finger on the real nitty-gritty problem of disaster response and planning, is how can you pre-plan for recovery? And there are a number of people, in fact, Mary Camario in the engineering department here is at the forefront of those efforts. A lot of it still is gathering lots of data, the kind of quantitative data from recent big events in developed countries, Chile, New Zealand, Japan, and trying to pull out the data in such a way, keeping in mind different cultures, different incentives. We're very much at the beginning of that. And actually, Rich Eisner here probably knows more about recovery issues than I do. Rich, do you want to throw in a word or two?
I would just segue into another issue, which is the probabilistic events. Because we plan for probabilistic events, and we keep seeing possible events. We see Tohoku, which was not a...
Right.
It wasn't on the probabilities. The event that occurred 2 days before was a probabilistic event.
Right.
And all the planning, including the land use and development planning, the emergency systems, the seismic networks, were all designed within the constraint of what was likely to happen. They didn't get it. So we have to start thinking differently about exposure and dealing with that in land use, just removing people from the coast side, which is what they did in Crescent City, which nobody likes.
Right. It's interesting to watch the recovery in Japan right now. And not too surprisingly, they are, at least in most of the cities I'm familiar with, all of the residences are being moved outside of the maximum extent of inundation in 2011. That's clearly an emotional response. I mean, you can kind of understand that nobody wants to live within that zone. When you realize that, you could have walked out of your house in plenty of time and been safe, that still doesn't work. So trying to figure out how to rebuild in the emotional environment of a major disaster is hugely problematic when there's no land available. I mean, literally, they're cutting off the tops of mountains in order to create spaces for people to live in an area that's already economically depressed. So the issues, recovery is really problematic. And it's not my field of expertise, thank goodness, but it's definitely something that, as perhaps we look at more catastrophic events affecting large population areas, which will happen even if because population is expanding. It's something that societies are going to need to do a better job of dealing with.
Okay, and with that, let's thank our speaker.